There is several type of lathe tools, from knurling wheels to boring bars. The most common type of lathe tool is the knife tool. This can be either left hand or right hand. There is also types of forming tools for making grooves and radius, and 45-degree tools for making chamfers. There is also specialist tools for screw cutting threads. Boring bars are similar to knife tools, but with a thinner and longer body and are used to machine internal holes. Another specialist tool is a knurling tool, comprising of two adjustable wheels that cut diagonal patterns into the diameter, used for hand grips or sometimes when something like a small cogwheel is to be pressed onto a shaft. Knife tools are generally used to turn the diameter along the axis of the workpiece. They can also be used for machining faces at 90 degrees to the workpiece axis, or either by using a taper turning attachment, or using the tool post set to the desired degrees, for machining tapers. Forming tools are more generally used by moving the tool against the axis of the workpiece. The speed for these tools is greatly reduced due to the broad cutting areas. It is vital that all tools are set at center height. The easiest way to do this is using the point on the center mounted in the tailstock to visually set the tool height. With tungsten carbide tipped tools, sometimes called indexable tools, there are two main types of knife tool. A roughing or general purpose tool, which has a shallower rake angle, and a slight radius on the cutting edge. The other main type is a finishing tool. This has a much sharper cutting edge and a much sleeker rake angle. For this demonstration we shall focus on a general-purpose knife tool. The nearest edge to the direction of travel of the tool should be set so it is at 90 degrees to the axis between the centers of the lathe, head and tail stocks. This is not only so the tool can cut cleanly and truly, but so the edge also leaves a square face. It also means that the cutting edge has the lowest possible surface area working the material of the job, keeping friction to a minimum, and helps prevent premature tool failure and assists with keeping the work cooler. It also helps prevent chatter and allows for a quieter cut. The compound slide, on which the tool post is mounted, should be set so that its operational axis runs parallel to the desired main cutting axis. i.e., if a plane diameter is to be turned, then the compound slide should be set to 0 degrees, and be parallel to the main center line axis of the lathe. This is to allow finely controlled adjustments to be made for facing and also for getting the tool safely to the edge of the work, but with practice, the latter too can be learnt with skill on the main saddle handle, even more so when used in conjunction with a digital readout. When a taper is needed, and no taper turning attachment is available, the compound slide should be set to the desired angle of the taper, i.e. 15 degrees, and the feed controlled by hand. It is recommended that this is returned to 0 degree after taper turning is completed so accurate cuts can be placed for facing off. Ferrous metals, i.e. steel, and materials such as plastic and aluminium should be turned using a water-soluble coolant. If a coolant pump is not available, a washing up liquid bottle works well. You can also use a spray bottle or even something like WD-40, especially on aluminium, will work okay. Plain motor oil can be used, but this doesn't work as well. You should avoid using coolant when turning cast iron or brass, as the fine filings form these materials will build up in the sump or T-slots of the machine. For machining cast iron, it is recommended a face mask should be worn due to the graphite dust that is given off. Coolant, where used appropriately, can extend the life of a tool and aid its machine finish quality. Should you find your work finish a bit on the rough side, you can try changing the tool tip, but remember, most tungsten carbide tipped tools give a better finish when working hard. If all else fails, there is no shame in using a fine bit of emery cloth to polish the work bit. Rule of thumb for speeds and feeds is, the larger and harder the material, the slower the spindle RPM is set to. The better the finish requirements or the harder the material, then slower self-feeds are needed. When reaming holes, the spindle speed should be half of that used for drilling. Forming tool speeds are much lower than standard turning speeds, and depends on the spec of the material.